Hello, ma'am. Hello, ma'am. Hello, ma'am. Can you hear me?
Yeah, yeah. Audible?
Yeah, sure, you are audible.
How are you, Srivastava?
I'm very good.
Okay.
Yeah.
Had your lunch?
What?
Had your lunch?
How do you know I didn't have my lunch?
Yeah. You're ready to start?
Yes, sure, I understand.
Okay. So today we are going to start gravitation chapter. I hope you have a little idea about this chapter,
Yeah.
the terms. Yes?
Yes, sure.
Okay. So what can you explain solar system? What idea you have about solar system?
About the solar system, what you're saying? I know it is starting from Sun to
Okay.
Pluto.
Oh, okay. So what is sun here? So here we
Wow.
see sun. Yeah. Okay, please tell me.
The sun is like the star, man.
Yes, very good. So around sun, the planets are revolving. Can you see in the picture? So
Yeah.
till Pluto, whatever you said, all those are planets. So how many planets are there overall? 9 planets. So all these are revolving around the sun, right?
No, there are only 8 planets.
Yes, Pluto was removed, right?
Yes.
Okay. So whatever the planets are there, they are revolving around the sun. And along with planets, what else are revolving? Asteroids, comets, whatever, everything are revolving around the sun. What's the reason why they are revolving around the sun?
Yeah, just a second. Just a second. Enter.
Why are they revolving around the sun? That's the question.
Okay, so they're revolving under the sun because just a second, I'm eating something.
Yeah, yeah.
Oh, sorry, ma'am, I just did something. Now let's get back.
Yeah.
Do you remember the question?
So basically, the question is why are the planets revolving around the sun, right?
Yeah.
So the planets are like revolving in the sun because
So planets are revolving around the sun or sun is revolving around the planets?
sorry, the sun is revolving under the planets.
Huh? Are you sure?
So the sun is revolving around the planets basically.
No, the planets are revolving around the sun. Why not sun is revolving around planets? So
Ma'am,
here,
I got little confused what you are saying, which
yeah,
question.
we have sun. Around the sun, the planets are revolving in a circular path. Yes? So all
Yes.
the planets, so they're revolving. So there is a kind of attraction between the sun and the planets because of which they are revolving.
Mm.
Okay, so what kind of attraction it is, what kind of force is existing between the sun and the planets? So that force is called as gravitational force. What force it is?
You are
Gravity.
interested in
Gravitational force, basically.
Yeah. So all the force, whatever you can see, they are revolving. So that force is called as gravitational force. So when you talk about the two objects, the two cars, when I'm taking two cars are there, two objects are there. So they're moving and going away. So whatever the attraction between them is called as gravitational. Okay. So the attraction between two objects is considered as a gravitational force. Okay. Now,
Yeah.
around the sun, let's say the similar kind around the earth. I have earth, and around the earth, moon is revolving. You know this? Around earth, moon revolves.
Yeah.
Yes, that's what you can see, moon. Okay, around the earth, moon revolves in a circular path again. So why moon is revolving around the earth? What kind of force it is? Again,
Gravitational force.
and next question is, the moon is revolving around the earth. Why not earth is revolving around moon?
Why not the Earth is revolving around the moon?
Imagine moon is revolving. There is an attraction between both earth and the moon. But only why moon is revolving around the earth? Why not earth is revolving around the moon?
Um,
Because of the size. So
oh,
the smaller one and the earth is the bigger one. Because of the size difference, only the moon can revolve around the earth. And the force of attraction between them is called as gravitational force. Okay.
Yep.
How it is revolving? In the form of a circular path. So what is circular path? Again, what is a circular path?
so wait, it's basically the planets move. That is just a second.
How can you explain circular path in your own words? Just explain me casually.
Yeah, circular path. Circular path is like where
Any example you can give to me?
the 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 all the planets are there, right?
Yeah, planets like
That
we can't see, just we know. So in
yeah.
your in your day-to-day life, can you tell me? Can you give me an example where you can find a circular path?
I think it's like in the
Physics
solar
can
system, in the
work
solar.
as well. Yeah, that is like we cannot see, right?
Mhm.
In your day-to-day life, in your regular life. So from morning to evening, whatever you see in those, where you can find the circular path.
Okay, so
See your roof. What
yeah,
color?
I can see. I can tell you. I can see it like up on the wall.
On the wall, what you have on your roof?
So,
Do you have a fan?
so I have a fan on
How
the
it revolves?
wall. Yeah, it has a circular line.
Around the central axis, there is a center. In the fan, you can see in the center there is a motor. Around the motor, the blades are revolving, right?
Yeah, there's the blades.
Yeah. So around a certain axis, the blades are revolving in a circular path. So that at a particular axis, if you see motion moving in a circular path, then it is called as circular motion. Okay, same thing is happening. Earth here is central axis. Around the Earth, moon is revolving, and this is called as circular motion. Okay,
Yeah,
clear.
yes.
Okay. Next thing, we can see the circular motion with an activity. Okay. So what activity? Here we took a battery. You know battery, right?
Yep.
This, I think you can perform this activity also. This is a battery. We took to the battery, we attached an electric motor. Okay. To this electric motor, A plate, on the plate you can see a wooden block is arranged. Okay.
Yep.
Now if I start my battery, then electric motor starts working. Yes.
Yep. Yes, sure.
So if it is working, then this circular plate starts to rotate.
Yep.
How it rotates? The plate, whatever the plate you have, so that plate rotates like this. Can you see? Rotate
Yeah.
like this in a
Yeah.
circular path. Whenever you see from the top, whenever you see from the top, so when you see from the top, you can see this kind of motion. This is called a circular motion. Understand? This
Yeah.
is an activity which we perform to confirm circular motion. Clear?
Yep. Sure.
Okay. Next, coming to the gravitational force. We can also, so what is gravitational force? Let's write down the definition of gravitational force. Gravitational force. So the attractive force between the object, attractive force between the objects. So there is a condition where this particular gravitational force exists. So what condition it is, whatever the objects you are considering, whatever the attraction you can find between the objects, that object should have mass, having mass. Like I told you, two cars, you can take an example in between two cars, and in between this pen and me, there is a kind of attraction. So pen is having certain mass and I am having certain mass. In between both of us, there is a kind of force. That force is called as gravitational force. Can you repeat the definition?
Attractive force between the objects having mass is known as gravitational force.
Yes. So you understand what is gravitational force?
Yeah.
Okay. So now this gravity, there is a particular law called as universal law of gravitation, which is very important for your exam. So what is universal law of gravitation? So this was explained by Sir Isaac Newton. So Newton proposed this law, and this is the universal law. It applies everywhere. Okay. So we talked about gravitational force earlier. So in physics or in anything, instead of taking the entire name, we just indicate a particular name with a symbol. So that particular symbol for gravitational force we are using is F. Okay, what is the symbol we are using here? F. So gravitation force F. So this gravitational force depends on what, as I told you, one of the condition is it is depending on the mass of the objects. Whatever, wherever you can see the attraction between any two objects, so it is depending upon the mass. So here I am considering two bodies, like two objects I'm considering. One is a bigger object, another one is a smaller object.
Smaller object.
Okay. So
Yeah.
both are having masses or not?
Yeah, both are having masses.
Okay. Can you tell me how can you measure mass?
Mhm.
If I give you a cover of tomatoes,
Yeah, sure.
okay, I asked you how much mass or how much weight these are. How can you tell?
By measuring the size of the tomato.
Size?
Yeah.
Don't you use any common balance or weighing machine?
Hmm. Yeah, we don't need to, we don't need to use those. We can use a weighing machine.
We can use a weighing machine. So on that weighing machine, you get a particular number, right?
Yep.
That particular number is measured in what?
That particular number will be like measured in kgs.
Very good. So mass is measured in kgs. So it also measured in grams. Okay.
Yep.
Understand? So
Yeah, understand.
yeah. If your mother tells you to bring tomatoes, then you'll ask you like how many kgs of tomatoes I have to bring, right? Same
Sure.
thing. So here the big object mass I'm considering as capital M, as it is bigger one. Okay.
Yeah.
And the smaller object masses I'm considering as smaller. I told you for everything, like we use a particular letters to indicate. Mass is generally indicated in M. As it is bigger, it is capital M and smaller object is smaller. Okay.
Yeah.
And the distance between the two objects. How you're going to measure the distance between two objects? How will you measure? If I give you a scale to measure the distance between two objects, where do you place scale?
That is a, if you give me a scale, right?
Yeah. If I give you a scale and I told you to measure distance between the two objects, how you're going to measure? Where do you place your scale here?
So I'm like the base in the middle of the two circles.
No. You need to start, if this is the center of the body and this is the center of other body and this is the distance.
That only I said in the middle.
Yeah.
And the
From the
sense,
center of one object to the center of other object, we place. We consider this as D. What is D stands for? D for distance. Okay.
Yep.
So bigger object mass is capital M, smaller object mass is small m, and the distance between two masses is considered as D. D for distance. Now, this gravitational force depends on what factors? So it depends on mass of both the objects. So that what dependent is shown as a proportional symbol in the formula. So I told you gravitational force is indicated by letter F. F is directly proportional to the masses of the objects. What does directly proportional mean? Okay. I hope you know the symbol.
yeah.
What does it mean?
So it means like it is directly proportional. Like
It is directly related. It is dependent. If mass is more, then force is more. Because if this is more, the other should be more because they are directly proportional. If mass of the two objects, that is product of mass,
gravitational force is directly proportional to mn, the product
MN,
product of mm.
yeah, product of the two mass.
By the square of the by the square of
No,
the
these are like different masses. You cannot square it. This is the bigger object, right? Let's consider I'm considering 100 grams. This is the other one. I'm considering 80 grams. So can you square it? You can
no,
only multiply it. You cannot square it. Understand?
yeah.
So these are like different masses. So we are considering the product of the masses only. No square here. And this force depends on the distance as well. So how it is dependent means inversely dependent. So this force is inversely dependent to the distance. What distance? Square of distance. What distance? Square of distance. What does inversely mean? Inversely is generally shown by 1 by. What does it mean? Srivastava?
It means like f is directly proportional to
Directly means I said if this is more, this is more.
yep.
Because these are dependent. What does indirectly mean?
Indirectly means it is not directly. F is not directly proportional.
Yeah, if distance is more, then force is more or less.
And force, if it's directly proportional, right?
No, in case of this formula, if distance is more, then
Then that
force,
will be less.
yes, that's what inversely means. Understand?
Yep.
Inversely means if one is increasing, the other should decrease. Okay.
Yeah.
So if I write this together,
F1 is what? F1 is what? Excuse me, F1
if
is?
one is more, if this is more, distance is more, this is going to be less. Here, in case of force is more, mass is more, as it is directly. If mass is more, then gravitational force is also more. If distance is more, then force is going to be less. Because see, if two objects are closer, there is more attraction. If two objects are far, then there is less attraction, right?
Yeah. So if the distance is more, then that.
Like attraction is less, that's what force is less. You understand?
Yeah.
Just
So what I'm
consider
saying is, sorry, if mass is more, then the distance is.
mass, mass and distance, no relation.
So if the mass is more, then
Force is more.
okay, okay.
Okay, simply you can consider example of magnets. If two magnets are closer, what will be the attraction between them? You know magnets, right? Have you ever played with magnets?
Yep, yep. I played with magnets.
Okay. If two magnets I'm placing like this, two magnets I'm placing like this, what what happens? What is the attraction between them? Here, more attraction or more attraction?
Here, right? It is more.
Here, more, right?
Yeah.
When the magnets are closer, they're going to attract with one another. If they're far, there will be less attraction between them. So you can say that if distance is less, if they are closer, means distance is less, then attraction is more. Here, the distance is more, then attraction is less. Understand the same point here. The two bodies you can imagine like a two magnets, two objects. Understand?
Yep.
If I combine this formula together, what I get?
So if that is big, this is small, right?
Yeah. So now I'm combining two things together. Like force is directly proportional to masses, inversely proportional to distance. Am I correct? Did I mention correct?
Yeah.
The two things combined together. This is the formula. And whenever you remove any proportionality from the symbol, any proportionality symbol from any formula, you need to add a constant. What you need to
Yep.
add?
I need to add a constant.
Yeah,
Yes.
I'm placing equal to here and I'm adding constant, which is capital G. This is the formula of gravitational force. This is the final formula of gravitational force. What is the constant we introduced here, Srivatsa?
So the constant which we introduced here is like the gravitational force.
G, G. This is the
Yes.
gravitation force.
Oh,
This is
sorry. So G is the constant
constant we have added. So what
which
is the
we
formula?
introduced. So the
Then
formula is F
to
is equal to G M by
D
D
square,
square. That only I'm squaring. The square of the direction.
square of the distance.
Distance. Sorry, I forget sometimes.
Yeah. Now, after learning the formula, learning each term is very, very important. Let's discuss each term. What F is here? Gravitational force. So gravitational force is F. What is M? Mass of bigger object. What is small m, Srivatsa?
So the small m will be like first I'll write the definitions. Yeah, I'm writing still. Just a second.
Okay. You're good at maths, Srivatsa?
Yeah, I'm good at math.
Okay.
So then,
Let's see how you derive formula. The next formula.
yeah, mass of bigger object.
Done?
Yeah. M is equal. M is equal to now the next one. Latest
Small
one.
m is? We use two terms. One is capital M and one is small m. What does small m mean?
Small m means like mass, and then this full M means masses.
Yes, small m and capital M are masses. So what is the difference between the small and capital? Why we use two
Oh,
different?
sorry, ma'am. The big M, oops, sorry. The big M is the mass of the bigger object, and then the small m is the mass of the smaller object.
Very good. Mass of smaller object. Perfect. Then what is D Vatsa here? Srivatsa?
Oh, sorry, I'm writing something here. So D
Done.
is the distance.
Perfect. Distance between the objects.
Like more smaller and smaller, please. Please, not.
So, ma'am, let's do the next one. The G is
Next,
the
what is
gravity.
G? G, when we got the term G here, what we did, we removed,
Gravitational.
yeah, we removed proportionality symbol and we added a constant, right?
Yeah.
The constant we added. What constant? It is gravitational constant.
Yeah.
Okay, G is gravitational constant. F is gravitational force. Capital G is gravitational constant. So you have to be thorough with the names, with the terms. Each term, like each letter indicates which. Okay.
Yep.
This always a constant, like gravitational constant, it has certain value which you need to memorize. Okay.
Yeah.
There is a value for G and that you need to memorize. It won't be given to you in the numericals while solving. So you need to memorize the formula.
Yep.
Value is 6.7 into 10 power minus 11 Newton meter square per kg square. This is the value you need to memorize. 6.7 into 10 power minus 11. Clear?
Yeah.
Now, how I got this unit? See, don't by the unit. You have to
Yep.
derive unit from the formula always. It's better you learn unit, deriving unit from the formula.
Yep.
Okay. For what I derived unit for G? From this formula, how can I make G here? How can I make G here? As you told me, you're good at maths. Can you make G to the left and rewrite the formula?
Okay, I can tell you. So minus G.
Minus G.
Yeah.
Is it plus? You have plus here to make it minus.
No.
It is multiplication. In
Oh,
case of
sorry. So if I take it that side, I thought it will become a minus because I'm used to algebra. So
right.
basically, if you take G to the left, no, and then I have to take the F back to the right side, right?
Yeah.
So G is equal to FMM by D square.
G, no. First, what we need to do is we have to do cross multiplication.
Oh, when that. So that will be a question mark.
Yeah. So F D square is
So
equal
FD
to
square.
G
GMMX.
mm. You
X.
need G, right?
Yeah.
So G is equal to, or I can write this one as GMM is equal to FD square. Can I write?
Yep.
As it is equal, I can flip simply. I need only G. And I don't want these two. What I have to do? Send the two things to the other side. When I
Yep.
send two things to the other side, they comes to the denominator as M and M. As there is a multiplication between the terms, when they reach to the other side of equal to, they become division. Like they comes to the bottom. From numerator, it becomes to the denominator.
Hmm.
Understand?
Yeah.
So what is the formula of G? G we got, G is equal to FD square by M and M. See, if you're
Between
confused, I can tell you the another way of making G. You're clear with this, or do you want me to teach you the other way?
No, I'm clear with that.
Okay. So G is equal to FD square by M and M. So I need units. So units can be derived from the each term. So now what is the unit of F? What is F?
F will be force.
Force unit is
Force.
measured in
FF.
force unit. You said mass is measured in kgs, right?
Hmm. So
Then
force will be measured in
unit of force is
like meters, right?
uh-huh.
Mass. I mean,
Mass is measured in kgs. Then force is measured in
like
unit of force is Newton.
yeah, Newton.
Okay, so Newton is indicated by the symbol N. So I'm writing N here as it is Newton. Then what is D?
D is distance.
Distance is measured in
Distance is measured in oh kilometers.
very good. Then it also measured in meter. You can
Meters.
measure in centimeters. Okay, there are many units for distance: kilometer, meter, centimeter. So I'm using meters here. Okay,
Hmm.
as it is square, I'm using square. There are two distance square, so unit is meter square. Understand?
Yeah.
By you told me mass is measured in mass is measured in
Mass is measured in hmm. um mass is measured in I told you no that I told you mass will be measured in kgs.
very good kg. So there are two masses. So each mass kg into kg. So it becomes kg square. So what is the formula? So what is the unit for the G? Newton meter square by kg square. Understand?
Yeah, Newton square by kg square.
Newton meter square by kg square. Please note down.
Sir.
Deriving units from the formula is very important. And better you learn in the same way. Don't memorize the unit exactly. Learn deriving units from the formula itself.
Yep. Yeah, the one I wrote.
Done? Okay. So G. What is G here? What is G?
Gravity.
Gravitational?
Gravitational force.
No. Gravitational force is F.
F.
Is
Oh,
it?
sorry. Wow. So G will be gravity.
Gravitational constant.
Constant.
Constant we introduce after removing proportionality symbol. So the G, it doesn't depend on, does not depend on what factor it doesn't depend on the size, shape,
Shape.
and medium.
Medium also.
Medium means like air medium, whatever the medium you have, still gravitational exists. The air medium in water medium, okay, still the gravitation exists. And this doesn't depend upon the size. Whatever the size, what kind of shape it has, still there is a gravitation in between them. Okay.
Yeah. Yeah. Okay.
Now, from the formula, can you write definition of gravitational force from this formula?
So you're saying me to divide?
Yeah, this is the formula we have for, this is universal law of gravitation formula, right?
Yeah.
Can we write definition from the formula?
Mm.
Okay. This is what gravitational force, let's write. It states that every object in the universe attracts each other. Do we discuss this point or not?
Yeah, it explains that point.
Yes. Every object in between two objects, there is always an attraction. Okay. And that force, with what? How it is attracting? It is attracting each other with force. What force that is? What force? With a force called gravitation force. Gravitational force. Am I correct or not? Whatever I mentioned, is that correct?
Yeah.
So it states that every object in the universe, it attracts each other with a force called gravitational force. And that gravitational force is, which is directly proportional to what? Directly proportional to? This force is directly proportional to?
Universal, just a second. Gravitational in the every object in the universe attract. Sorry, each other.
You answer the question. You
Yeah.
can't just.
Sorry.
Done?
Okay, fine. What's your question?
You're done? So
Yeah.
I stopped at a point which is directly proportional to what? The gravitational force is directly proportional to, from the formula, tell me, we derived. It is
Oh,
directly.
sorry, the gravitational force which is directly proportional to
Hmm? Look at the formula.
the product of masses.
You have gone through the definition.
Is it wrong?
Yeah, you're correct. Very good. So it is product of masses, that what we derived. It is force is directly proportional to masses.
Masses.
Masses, product of masses. And inversely proportional to?
Yeah, and inversely proportional to the square of the distance.
Very good. Inversely proportional to
To the
the
square of the distance.
square of the
Of the distance.
distance. Distance of what? Between the objects.
Yeah, between the objects.
That's the formula. This is universal law of gravitation. This is very important question in your exam. Please make a note.
Yep, sure.
You're writing?
What?
You're writing?
Yeah, I'm writing. I forgot. You are working on a problem? I'm right. Just a second.
You're done?
Yeah, almost.
Let me know once you're done.
I wrote it, mom.
Okay. Next, properties of gravitation force. What are its properties?
Yep. So basically the property.
So what are the properties of gravitational forces? Gravitational force. One is it is an attractive force. What is the first point? It is an attractive force, isn't it? So
Yeah.
whatever the force which is the attractive force between the two objects is considered as a gravitational force. Okay.
Yeah.
Okay. Next question I have a question for you, Srivatsa.
Yep.
See, I'm taking two bodies. I'm taking a pen here and a pencil here. Okay.
Yep. Very full.
Is there attraction between the two bodies?
They're little, very little.
Yeah, still you have attraction, right?
Yeah.
And you have attraction down towards Earth.
Down, I mean, down, we don't. It is
We don't.
far.
Why? If you drop the pen or pencil, where it is going?
Down also it is close.
It is going down. It means the Earth, whatever the Earth is there, it is attracting the two bodies. If you drop something, where it goes?
Down. Down.
Down only, right? Why it is
Yeah,
going
because of gravitational
of
force.
the gravity? Because of the gravity of the Earth, the particles are moving down. And you told me there is attraction between these two. There is also attraction between these two. So why only the two bodies are going down? Why they are not coming towards each other? You got my point? Here
They're not coming towards each other due to because of the gravity, it will fall down.
yeah, here you have gravitational force, right? In between two bodies, we have a force that is gravitational force. And here also you have a gravitational force because of which it is going down. Because in between the pen and earth, you have a force. And here also you have a force, which is again a gravitational force. So why only these two particles are going down? Why why they are not moving together?
They are not moving together due to it is more the gravitational force down.
Yeah, here the gravity is more. Here the gravitational force is weak. So that's what we can write. What gravitational force is a weak force. What force it is? It is
Weak
a
force.
it is one of the property because of which there is no attraction. Like there, the two objects they never attract much compared to the earth and the body. Okay, so it
Yeah.
is weak. And we discussed it is independent of the medium. It doesn't depend on the medium. In any medium, it can work. Even in the air medium, water medium, we discussed. So independent of the medium. Okay, independent of the medium.
Yeah, independent of the medium.
Independent. What does independent mean?
So the independent is like basically means it is not dependent. It is
Yeah,
far away.
means not dependent. So it is
Not
not
dependent.
on the medium. Please mention these 3 points.
Okay.
Gravitation force.
Yeah. You want me to write that something? You want me to write? You mean?
Yeah, yeah. Please write down.
Unity. You have experience book, right? Where is the experience book? Is it book? Where do you feel the left of source? Okay, terminology. No, let me wait. Don't waste time.
Now, can you tell me what is gravitational force, Srivatsa? Can you explain me what is a gravitational force?
Okay, I'll explain what is gravitational force.
So gravitational force is the attractive force between the object.
You're turning.
Oh, I
Just
shouldn't.
answer me. Don't
Yeah,
say.
I didn't know actually.
Whatever you understand, just tell me. What is the gravitation force?
Sorry, it is an attractive force, basically.
Where you can see that. It is attractive force. Where?
Between the two objects, it's an attractive force.
Yeah, there is an attractive force between the two objects. And what is the condition? They should have certain mass, having mass. So what is gravitational force? Gravitational force is the attractive force between two objects having mass. Clear?
Yeah.
Okay. So gravitational force is directly proportional to.
So for gravitational force is directly, what do you mean? Gravitational force is directly proportional to the product of masses
Very good.
by
Inversely
this
proportional.
by this and inversely proportional to the square of the distance
Square
between
of
them.
the distance. This what we get, right?
Yeah.
Okay.
Whatever.
If I remove this proportionality symbol, what I get? What I
It will
have to.
be they'll not be proportional, they'll be indirect.
Yeah. If I want to remove this symbol and I have to place equal to, what I have to do? What I have to introduce here?
G.
Yeah. What is G?
Gravity of
No.
Earth, the Earth of the gravity of the Earth.
No. This is a constant, gravitational constant. So to remove
Sorry.
proportionality symbol, you need to add a constant. So what
Constant.
we are adding here? Gravitational constant, which is capital G.
Yeah.
Okay, don't say gravity, because gravity is also having another symbol which we'll learn in the next class. Okay, this is gravitational constant.
Constant.
So it is the gravitational constant.
Constant. So Gmm by d square. Clear?
Yep, sure.
What are the properties? It is an attractive force, as we discussed. It is a weak force. Next, it doesn't depend upon the medium. Clear so far?
Yes, sure, clear.
Next, applications of gravitational force. Applications mean where you see, like in the day-to-day life or whatever. Wherever you see gravitational force, tell me. First thing we can discuss is simply the solar system, right?
Yeah, right.
Revolving of planets around sun. Can we discuss? It's a gravitational force.
Yeah.
Whatever the planets are there, all are revolving around the sun due to a force of attraction between them. That is called as gravitational force. So planets revolving around the sun. This is the application of gravitational force around the sun. Next, another we can discuss like the moon. The moon revolves around the earth. This is also application of gravitational force around the earth. Okay, next in the tides. What is tide?
First, can I please copy the definition?
Yeah.
Thank you.
You know Telugu?
Yep, I know.
Okay.
Yep, tides.
Okay, what is a tide?
I don't know what tides are.
Tide. We can see in what
Our
sea.
time. Yeah, we can see our time like at the right side at the bottom of our screen.
No, tide.
Tides. Sea or tides.
Tides.
In Telugu, alalu.
What?
Alalu. Have
Sea
you
or
ever gone to beach?
Yeah, I went to the beach.
Yeah, beach లో ఏమొస్తాయి నాన్న అలలు ఉంటాయా?
ఫిష్లు ఉంటాయి.
బీచ్లు ఉంటాయి, అలలు రావా?
అలలంటే tides వస్తాయి.
అలా టైల్స్ కూడా వస్తాయి.
టైడ్స్ పెద్దగా చిన్నగా వస్తాయా అలలు?
అంటే వేవ్స్ కదా, వేవ్స్.
యా
వేవ్స్ వస్తూ ఉంటాయి.
యా దే ఆర్ బిగ్ అండ్ స్మాల్ వేవ్స్, రైట్?
Yeah.
So that also the big and small waves is also due to the gravitational force. Okay, so these are the applications of gravitational force.
Yeah, due to the application of the gravitational force.
Where you can see gravitational force, one is you can see in the solar system where planets are revolving around the sun, then moon revolving around the earth, then in case of tides also we can see gravitation force. Okay, so these are the applications.
Yeah.
Let me know if you have any questions in the whole session.
I don't have any questions.
Any
Everything-
doubts?
No doubts. Everything is
Clear?
clear, very clear.
Okay. In the next class, I'll be giving homework, like certain questions to solve. Okay?
Yeah.
Okay. See you in the next class, Srivatsa.
Yeah. Bye.
Bye.
Thank you.